Okay, we're back. I'm going to get us going on a new data set. We'll revisit the happiness data in a little bit when we talk about doing some graphs, but let's look at another set of numbers, a little bit different kinds of numbers. Let's just assume that this is a small class of statistics, maybe. They take an exam, and these are the scores on the exams, okay? Again, this is a fairly small data set, but any of the techniques that we're going to learn for descriptive statistics for a data set like this could be applied equally well to a data set that is, 10 times the size of this. So I want to make sure that people understand that. I've said that before, but it's worth reiterating. So let's do some of our statistics that we have so far in our statistical toolbox. One of the maybe simplest and first things we should do is talk about how many people we have. So how many people took this exam? What is the size of our data set? Well, let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? So 17 student exam scores. All right? Another fairly straightforward statistic that we've done already is the mean, the average, and we're going to get that by adding up all the scores, dividing by the number of scores. So let's take a minute and do that, okay? You might want to pause the video. I guess when I say now, you can pause it, and then let's calculate the mean, make sure that we're all on the same page, okay? So you can pause the videotape right now. Okay, so hopefully you you had sum of all the x values. We're just going to add all the x values at what, 1302, I hope, divided by 17, and that gives us an average, a mean of 76.588. So that means 76.59, okay? That becomes our mean. So pretty straightforward so far, right? We have 17 numbers, add those together, divide by 17, we get our mean of 76.59. Now, by the way, in the last video we talked about a median, a calculated median value, and sometimes people are like, yeah, but nobody got that value, okay? And I'm like, well, listen, nobody got this value either, right? This is a calculated average from a set of whole numbers. We get this value. Okay, that's okay. That's our calculated value of the mean. All right. What else can we do here? Well, remember, I said that the range informs the mean. And again, this is worth repeating. Hint, hint. Okay, that we could get this mean if all of our test scores were between 70 and 80, let's say, okay? We could get this mean if all of the test scores were between, let's say, 73 and 78, okay? You can get a mean like this. Or you can get a mean like this with test scores from 10% to 99%, okay? So there's lots of different possibilities for the data set to give you a mean like this. In order for us to know a little bit more about what this value tells us, is we can get the range, okay? Everybody remember what the range formula is. That is, we're going to take the highest score, okay? We're going to subtract the lowest score. We're going to add 1, okay? So the highest score here, the highest score, 97, looks like 97 is the highest. Okay, and the lowest score is 45. So this is 97 minus 45 plus 1. So let me just check. I want to make sure I don't make a mistake. So we have a range of 53. The computations are pretty easy. When you get this value of 53, I'm going to ask you, so what does that mean? That means that these 17 scores cover a range on the number line of 53 points. Okay? If this average was just from numbers 70 to 80, our range would only be 11. Okay, 80 minus 70 plus 1. In this case, we know that the numbers are pretty diverse, right? There's a lot of variability here. It goes across 53 numbers, okay? By the way, I want to get back to this little equation here, highest minus lowest plus 1. It seems a little bit arbitrary to just add the 1. It absolutely gives you the correct answer. But why the plus 1? Well, it's a sort of a shortcut or shorthand to get the range. I'll give you the technically more correct formula for getting the range. This one is fine for you to use on the exam, and this will give you the same answer. But now that we know a little bit about upper and lower real limits, this isn't technically the equation. The equation is the upper real limit for the highest number, so that would be 97.5. The upper real limit for the highest number minus the lower real limit for the lowest number, so that would be 44.5. And that gives us, excuse me, that gives us our 53. Okay, it doesn't involve the plus 1 because we're using upper real limit for the highest number, lower real limit for the lowest number. You can use either of these formulas. I think this is the easier one to remember, but this is sort of weird that you just add 1 on. It gives you the same answer. Okay, so that's just an explanation of why we're adding 1. We have our n, we have our mean. Highest number is 75, lowest number is 45. I always like to think about that as part of my descriptive statistics because we could also get a number like this from different numbers, okay? Highest 97, lowest 45. Our range is 53. These 17 scores cover 53 units on the number line. What else? Let's get the mode. And the mode in this case is the most frequent score. So let's see what the most frequent score is. I'm looking through here. And in fact, I'll show you at some point how to do this on an Excel spreadsheet. You can put these numbers in and then sort them from highest to lowest, and it's easier to see duplicates or triplicates or quadruplicates or whatever. But, you know, I've done this before, and I've created a problem, and that is there are no scores that you see here twice. Each of these scores is unique. And so we're left wanting for a mode, right? What is the most frequent score here? Well, they are all equally frequent. That is, they all happen once. So in this case, I don't really have a mode, okay? This is something that sometimes, you know, freaks students out a little bit. Well, what's the answer? What's the answer? Well, in this case, we can't answer this question because there is no mode. There is no most frequent score. They're all equally frequent at 1, okay? So we'll just let that be for a minute. What other statistical tool do we have? Well, we could calculate the median. And again, what is the median? I'm going to ask you this on the exam, of course. Well, the median is the 50th percentile. And then, of course, I will, and this is absolutely true, okay? The median is the 50th percentile. But then I want you to go further. I want you to go one step further and tell me, well, what is the 50th percentile? That's the place in this distribution where 50% of the scores fall at or below. It's the place in the distribution where 50% of the scores fall at or below. Okay? So median is the 50th percentile, and then I want you to continue and tell me what the 50th percentile means. It is the place in the distribution where 50% of the scores fall at or below. Okay? By the way, I would recommend that you not try to memorize that you understand that concept. Because I've seen many people memorize or try to memorize that and get it wrong and it comes out all garbled. Okay? Take a moment, think it through. 50th percentile, where 50% of the scores fall at or below. Okay? Of course, in order to do that and to do it, to get a calculated median, I would want to set up my frequency distribution table. Okay? So that's what we're going to do next. We're going to set up our frequency distribution table. So I'm going to get rid of this. We'll get back to the median. I'm going to get rid of this for the moment. Okay. Remember, when we set up our table, we have our x values. Okay. And we have our frequency for each of the x values. And then we're going to get our percentage. I'm leaving out that the p column, okay? Because it's the same as percentage. It's just where the decimal is. So we're going to leave that out. I'm eventually going to get my cumulative frequency, and I'm eventually going to get the cumulative percentage, okay? I'll clean this up a little bit more in a minute. But we do have a bit of a problem here, or at least we start with a little bit of a problem. We're certainly going to fix that. When I list my x values, I'm going to start at the highest, okay, and I'm going to go down, keep on going down, right, until I get to my lowest value, okay? How many entries will I have in my x column in this case? How many entries? Think about this. I'm going to go from my highest to my lowest, inclusive. In fact, how many entries am I going to have? 53. Remember from our happiness data? I mean, one of the things that we need to do for this course is, I mean, it's ultimately cumulative, right? So whatever we covered in the last video, we're picking right up there, and I'm expecting you to sort of get what we covered the last video. And then we're going to move forward, move forward, move forward, move forward, okay? And remember, with the happiness scores, we were able to see kind of in a tabular form, we were able to see the range because we just counted up from highest to lowest and inclusive. And it was, what was the range there? 8, I think. We're going to do the same thing here. So we're going to have 53 spots. 53 spots in my frequency distribution table. Guess what? That makes things very cumbersome. And in fact, we're not going to do something that makes our data set more complicated. We are trying to distill this, right? Our descriptive statistics. We want to make it easier for someone to consume that information. I don't want 53 entries in my frequency distribution table. By the way, put on your thinking caps here. If I had if I listed all of these values, potential values, what would be the modal number that I would see in this column? What would be the most common entry I would see in my frequency column? Take a minute to think about this, okay? So I have all my numbers listed from 97 to 45. What am I going to see most likely, most often in this column? That's correct, zeros, right? Because I have 197, but I have no 96s. I have 195. I have 0 94s, 0 93, 0 90. No, I do have 192. 0 91s, 0 90s. There's going to be lots and lots of zeros. The point here, the big point is, I don't want a frequency distribution table that has 53 entries. It just, I mean, we only have 17 test scores, for God's sakes, okay? And so what I'm going to do in this case, you know, statisticians, academics, scientists, what we try to do is solve problems. So the problem that we have here is this frequency distribution table. Just there's too many entries. This is going to make this very difficult to look at, to consume. It's not going to be a good way to describe this data set. So what I'm going to do is I'm going to use what the book calls, I'm going to use class intervals. Rather than single numbers, I'm going to use class intervals. Now, I hope you wrote this in your notes. I hope that you're taking notes when you watch these videos. That's the process, okay? If you want to do well, that will help you do well. I'm going to use class intervals. This is something that you've probably never heard of before. And in fact, I don't particularly like the wording, so I'm going to do this. And sometimes people say, well, why did you have us write that down if you're just crossing it out? Hey, listen, you got to trust me at some level, okay? The book talks about class intervals, so I want to introduce that. I'm going to cross this out because that should be a reminder to you that Dr. Speck thinks this is confusing. Guess what? I'm just going to say groups. Instead of class intervals, let's just use the term groups. I'm okay with that. Are you okay with that? Good. Okay. So we're going to group these data. Instead of listing them as just single entries, I'm going to put scores together as groups so that our frequency distribution table is more manageable. It's not going to go from 96 all the way down to 45. Okay. We're going to put these numbers into groups. And we'll see that that makes things much more manageable. Okay? Now, what I'm going to need to do is I'm going to need to somehow chop up these numbers in groups that make sense. So we're going to have to think about the number of groups that we have. And we're going to have to think about the size of each group. Okay. And let me clean this up a little bit here. I do want to leave that range there for a minute, okay? Because that's going to be important for us when we figure this out. So how many groups are we going to have? And what is the size of the group? The size of each of the groups needs to be equal for this to work. That's one of the things we have to keep in mind. And to decide how to chop up these numbers takes a little bit of art, right? I'm going to combine art with my science and my statistics and my math. That is, what is my goal for creating a frequency distribution table? Let's keep that in mind. I'm not going to give you guys just a bunch of rules and you do the rules and you punch in your calculator and you get the answer and then we go on our way, because I've seen that done and people aren't learning anything about statistics. They're learning about how to do some rule thing. when you're working in an agency, when you're running your own company, when you're in a clinic, when you're doing research, you're going to be faced with some decisions that you're going to have to make, okay? And those decisions, you have to think about what your goal is. Like, what are you trying to accomplish, okay? So I want to put these data in a way that it's easy for people to see in a frequency distribution table. Let's think about why we did this. I want to see within this range, right? We have a range of 53. Scores go from 97 down to 45. We have a range of scores. Excuse me. I want to try to see how the scores, how the individuals are distributed within that range. I'll repeat that, okay, because it's very important. My goal is to see how the scores are distributed across that range. Now, I mean, the very best way to see how they're distributed across the range is to put 97, 96, 95, 94 all the way down to 45 and to put here's 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, right? That would be the frequencies. But that's cumbersome. Too many spots. So what do I mean by too many spots? Too many entries here, right? Well, 53 is definitely too many. Okay? But as soon as I make fewer, as soon as I do fewer spots, as soon as I start to group people, then I am sort of compressing this information. But that's okay. That's going to be the compromise I'm going to make. I'm going to compress some of these so that you might not be able to see all of the distribution that is in that much detail, but it's going to be easier to read. Okay? So here are some guidelines. And in fact, there is no rule. There are guidelines. If I have 53 spots here, that's just too much to look at. If I only have two groups, let's say I had, I said everybody over 70 and everybody under 70. If I just have two groups, well, I'm not going to be able to see much distribution, okay? 53 too many, 2 are too few. Well, what's the right answer? There is no single correct answer, okay? But the guidelines, I mean, I have rarely seen a frequency distribution with fewer than 4 groups, okay? If you get fewer than 4, you're not going to accomplish your goal. That is, you're not going to be able to see how the scores are distributed very well. If you have more than, let's say, a dozen, 15 at the most, I would say, then it starts to get cumbersome, okay? If you had 20 entries, that's no good. 25, no good. 40, no good, okay? In general, I can imagine a situation where that might work for something. I don't know, but it's too many for me. So somewhere between 4 groups and let's say 12 or 15 is really sort of the sweet spot, right? That's easy for people to see. Plus we accomplish this kind of ability to see the distribution within the range. Okay? So that's the first guideline. How many groups should you have? Well, somewhere between 4 and let's say 12 or 15. I think that's a good target. We want to make sure that the size of each of the groups is the same. Okay? So we want the same size. We want equal sized groups. So what we're going to do now is we're going to say, all right, how do you accomplish this, right? How do you accomplish this? Well, listen, I have 53 spots. That is, my numbers go across 53 units in a number line. That's what the range means. That's why I left this here. I want the size of each of the groups to be equal, so I need to split this up into equal size groups. okay? Groups of 10, groups of 5, groups of 4, groups of 20, whatever the group size is, I want them to be equal. However, I've created another problem here, purposefully. This is a prime number. Anybody know what a prime number is? A prime number is indivisible by other numbers except itself or 1. So I can't, it's impossible to break this up into a number of equal size groups. It's not divisible by any other numbers. I did that on purpose. This creates a problem for us. But it's a problem that we're going to solve. That's what you're here to learn, right? We're trying to solve problems. You're going to be exposed to problems when you're a professional, and your job is to learn a lot of stuff in college so that you're able to deal with problems once you encounter them, okay? I want equal size groups. This is indivisible. So this is how we're going to solve the problem. Now, I need to make sure that I cover 53 spots because the range of these numbers is 53. But there's nothing that says I can't do more than 53 spots, right? I can't do fewer than 53 spots. I can't do 53 because I can't chop that up into equal groups. But I can do more than 53. That is, if I have a frequency distribution table that covers more than 53 spots, then within that I have my 53, okay? So this is the actual range for this group of numbers. But when I'm chopping it up, guess what I'm going to do? I'm going to do this as my range, and I'm putting this in quotations because this is my range, 53. But 53 is a subset of 60. That is, I can go across 60 units. Boy, I like 60. And it's another reason why I use this example, okay? Because 60 can be chopped up in lots of different equal size groups. Let's think of a few, right? I could do 2 groups of 30. Well, but remember, if we just have 2 groups of 30, that's not going to work so well. I'm not going to accomplish my goal of seeing the distribution within the range, okay? I could do 3 groups of 20. Well, that's still not going to work so well. Only 3 groups. What about 4 groups of 15? 4 groups. So we have 4 groups of 15 each. That would give me 60. Now, what would that do for us? We'd have 4 groups that have 15 in each group. The range would be 15 in each group. 4 would not allow me to see too much distribution, right? Because I'm kind of grouping things together. But this would certainly work. This would certainly work, okay? What about 5 groups of 12? Right, I'm getting to 60 here. 5 groups of 12. All right, maybe that's okay. Maybe 6 groups of 10. Maybe 10 groups of 6. Okay. Maybe 12 groups of 5. You see there's lots of possibilities because 6 is divisible by lots of different numbers. And so we have a lot of different possibilities, all of which are technically correct, but which one do we want to use? Okay. One of the things that we want to keep in mind is I want to be able to see the distribution of scores. Let me get my eraser here that fell on the floor. We want to be able to see the distribution of scores, okay? So maybe more groups would be better, all right? 12 groups of 5, 10 groups of 6. There's another thing that we should pay attention to here, and that is the size of our groups the size of our groups should be a nice number. And sometimes, and that's a guideline, by the way. That's our third guideline. This group size should be a nice number. And hopefully you're dutifully writing that down in your notes, right? The size of the group should be a nice number. And most students do that when I teach this class. And then I wait for them to write it down, and then I say, okay, you wrote it down. Does anybody have a question? Yeah, like what is a nice number? Are there nice numbers and not such nice numbers? Well, the answer is yes, there really is, okay, in terms of your consumption of this information. Let's do this little thought experiment, okay? If I ask you to count to 100, not by ones, we're going to group our data. If I ask you to count to 100 by fives, how easily could you do that? Pretty easily, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? If I ask you to count to 100 by tens, pretty easy. 10, 20, 30, 40, 50, 60, right? If I ask you to count to 100 by sixes, 6, 12, 18, 24, right? It takes a little bit more time. So numbers like 5, numbers like 10, numbers like 20, numbers like 2, 2, 4, 6, 8, right? It's easier than odd numbers. Numbers like 18, numbers like 7, numbers like 13, numbers like 54, numbers like 127. Those are not so nice to think about in groups, okay? And we have to think about bigger numbers too. I mean, nice numbers could be 200. I can count by 200s. 200, 400, 800, or 200, 400, 600, 800, right? Counting by 130s, not so easy, okay? So we need to think about these numbers here should be nice numbers, okay? 12, not so nice. 10 is nice. 5, 6, not so nice. 15, I'm not sure. And by the way, this is also not an absolute. I mean, if we were counting by eights, let's count to 100 by eights. 8, 16, 24, 32, 40, right? Takes a little bit of thought. But if you had a company and you were bottling your product in 8-packs, eights, counting by eights might be really nice for you. And if you're in an industry where everybody, packages their products in eights, then 8 would be a nice number. For the general public, for us, 8, not so nice, okay? So I have some of my possibilities here to think about how we're going to put these numbers into groups, okay? And I want to keep my goal in mind. That's extremely important. I want to see the distribution. So probably the more groups I have, the better off I am. But I don't want to have 20 groups here, 20 groups of 3. I don't want to have 30 groups of 2, right? That's it's just too many. So those are out. Well, let's look at this too. I could have 15 groups of 4. Is 4 a nice number? Not quite so sure. But boy, having 15 would allow me to really see what's going on. But I'm not sure that I like groups of 4. Let me get rid of this. Okay. 6 groups of 10. I mean, 10 is a really nice number, right? 10, 20, 30, 40, 50, 60, 70. But it's only 6 groups here. It would only be 6 groups. What about 12 groups of 5, right? 5, 10, 15, 20, 25, 30, 35, 40. Kind of nice. 5 groups of 12. Nah, 12 I don't like as a nice number. 4 groups is kind of maybe not enough to see the distribution. 15, not sure that's a nice number. 6, don't like that. So I've sort of whittled this down a little bit to these two possibilities, okay? And I'll show you how to group these in a minute. And perhaps that will, I'm assuming that will make it clearer for us too. But I want to talk about 12 groups versus 6 groups. If my goal is to see the distribution of scores within the range, 12 groups might be better to use, okay? Because it's going to expand those groups a little bit. I'll be able to see the distribution. That is 12 groups compared to 6 groups, okay? So what I'm going to do is I'm going to use, 6 groups. Now, I hope that shook you a little bit. I hope you're like, I thought you just said 12 groups would be better. 12 groups would allow us to see the distribution of scores in the range a little bit better. However, there's another consideration. What did I say that these numbers represent? That's right, exam scores, okay? We are used to seeing exam scores reported in deciles. Everybody know what deciles mean? It means in the tens, right? You're used to seeing like how many people got in the 90s, how many people got in the 80s, how many people got in the 70s, so on and so forth. Those are deciles. We're not used to seeing them in fives. What I want to do with my descriptive statistics is make it easy for a consumer, whether that's me or whether it's someone else, right? Whether it's your agency, whether it's a government office that you're sending this information to, whether it's the dean at the school, or whether it's me looking at my own class performance, I want to make it easy to look at and easy to consume, okay? Since test scores are typically done in deciles, I'm going to do 6 groups of 10, okay? That sort of overrides some of my other considerations. 12 groups of 5 will definitely let us see more distribution, okay? That is where people are in that range. But it's such a powerful, using deciles for test scores is so common that that's what I'm going to use. Okay? Now, if these were heart rates, another reason I use this example, because I can talk about, various alternatives here. If these were heart rates, absolutely I would use this. I would absolutely use this strategy for my grouping, because then I'm going to be able to see that distribution. You see what I mean? I'm always maintaining my goals. What do I want to accomplish? Okay. And by the way, this is just a general strategy for me in my professional life. I do a lot of meetings with a lot of people, and oftentimes people will start doing things, and I'm not sure why people are doing what they're doing. I'm sure you've had that experience as well. And I raise my hand and I say, well, what is our goal here? What is our goal? I mean, my goal for this stats class is to teach you strategies about how to do descriptive and inferential statistics. I'm not here to create busy work for people. That is not my goal. I'm sure you've taken some classes where professors have you do stuff and you don't even know why you're doing it. If you don't know why we're doing something in this class, please drop me an email, okay? I'll always try to explain why we're doing what we're doing. So this is a big explanation, and now I'll show you how to do this. If these were heart rates, I'd use this because this gives me 12 groups to really see the distribution, okay? Since these are test scores, I'm going to use 6 groups of 10. Okay? Let's do it. Let's do it. I'm going to write something down right now that I don't want you to write in your notes because it's the wrong way to do this. Okay? Well, no, I'm going to skip that. Sorry. So when we make our frequency distribution table, there's yet one more guideline. Wow. How many guidelines do we have? Well, the number of groups, the size of the group. We want to make sure that we keep track of our goal of seeing the distribution. Number of groups, size of groups. We want the size of the group to be a nice number. And another guideline is the first number in your first group should be a multiple of the group size. Wow. That is not something that you should memorize, okay? Here's what it looks like. I'm going to do this. 40 is going to be my first number. I want to do, let me move that down a little bit. 40. I'm going to do a group size of 10. So I'm going to go 40 to what? 40 to 49. And people are like, isn't that a group size of 9? No, it's not, because this is a little mini range. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. That's 10. If we went up to 50, it would be a group of 11. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay? That's a group of 10. 50 to 59. 60 to 69. 70 to 79. 80 to 89. 90 to 99. Okay? Notice how much easier this is. 40, 50, 60, 70, 80, 90. We're in the deciles. Then if I had started with 45 to 54 and 55 to 64 and so on and so forth, or God forbid something like, 43 to 52, or it would just look cumbersome. The first number in our group should be a multiple of the group size. It's a multiple of 10, right? We're using this strategy here. 6 groups of 10. 6 groups of 10. 6 groups of 10. Okay? And it sort of corresponds to letter grades too, right? I mean, that's how powerful deciles are here. If these were heart rates, I would absolutely use 12 groups of 5. Okay, I would absolutely use 12 groups of 5 if these were heart rates. Why would I do that? Because it would allow me to see the distribution within the range a little bit better. It would expand that out, okay? But I'm not going to do that. My actual range of 53 will fall in here because 60 subsumes 53, right? 53 is a subset of 60. Okay, cool. Are we cool? Okay. It's not easy, right? It takes some time to go through. I mean, there is no correct answer. If you wanted to do 12 of 5, you can do that technically. I don't think it's the best way. Oftentimes, I share my frustrations with my students because people want to know, well, what's the answer? Well, what's the right answer? What's the right answer? Listen, all of those options that I put down here are potentially, they're not wrong. There's usually not a right and a wrong answer. There's usually a wrong answer and a number of other possibilities, and I'm always searching for the best, okay? So what we're going to do now is we're going to put in our frequencies for these numbers, right? So how many people were in the 40s here? How many people were in the 40s? 1. So we have a frequency of 1 here, okay? How many in the 50s? I think it's 1. Okay. How many people in the 60s? 1, 2. Okay, 2. How many people in the 70s? 1, 2, 3, 4, 5, 6. How many people in the 80s? 1, 2, 3, 4. How many people in the 90s? 1, 2, 3. Okay. Now, have I made a mistake? Well, I know my N is 17. The frequency column should add up to 17 then, right? 1, 2, and 4. 6 is 10, 14, 17. Okay? So I think I'm good to go. Now, for the next video, we're going to start with this table completed. So I'm going to ask you to complete the table. See if you can get your percentages. We're going to get cumulative frequency. We're going to get cumulative percentage. Okay. If you have questions, make sure you drop me an email. Okay. I can either answer questions via email, or we can set up a Zoom or a FaceTime to talk about it. All right. We'll see you next time. Fill in the table, and we'll go from there.